Day 1, Understanding Rational Exponent and Radicals. Content statement: the student will be able to define rational exponents in terms of roots. Language objective: a student will explain to their partner how to write rational exponents in terms of roots. Okay, so let's go through our review. So the first one is called a square root, or in some textbook they will call this the radical. Okay, so this notation is also called a radical. The second one is called the cube root. The reason called cube root is because of this number 3 here. Okay, so then we see that there's number 3 here, so let's go back to our square root. Right? For the square root, there's a 2 here that we do not normally write. Now the end root. So the end root is this notation, right? So then this upper right hand number is called the index, and the number inside this the radical is called the radicand. Right? Note, when a number has more than one real root, the radical sign indicates only the principal or the possible root. So for example, we can have a square root of 4, right? So square root 4, well, this could be plus or minus 2. The reason for that is that we have 2 times 2 will give us 4, or negative 2 times negative 2 will also give us a 4. Okay? But then when we have a square root 4 by itself, so we only want the principal or the positive root. Right? Okay, so this is the same one, so it looks neater. So the first one is called the square root, the second one is called the cube root, and the last one is called the end root. Right? So for rational exponent, for all real numbers a and all rational number m and n, the following way of expression the exponent n m over n are equivalent. So here we have a to the power of m over n can be written as the index n radical a to the power of m, or we can write it in this form, right? So okay, so then we can say that, so for example, if we have a to the power of 3 over 2 can be written as the square root of a raised to the power of 3, or we can write the square root, the square root of a to the power of 3. Okay, both are acceptable. Remember that for square root, there's 2 here that we do not normally write, right? So we want you to understand is that the denominator will become your index and your numerator will become your power. So similar here, the denominator will be your index and your numerator will be your power. Okay, and this is the same, right? So then this we can written as this, the n root of a parentheses raised to n power. Okay, so then here are some of the basic property, right? So they say that. So let's go through the first ones first. Any non-zero number raised to the power of 0 is 1. Right? So for example, our 3 to the 0 power is 1, 2.4 to the power of 0 is also 1. But then notice that this part here, 0 to the 0 power is undefined. Right? And then here, in terms of a variable, x to the 0 power is 1, for x must be a non-zero. Okay, so here we say that for any non-zero power raised to the 0 power, is 1, so we can have, say for example, we can have pi raised to a 0 power. The answer is still 1. Right? And let's go on to the second part. Any non-zero number raised to a negative power is equal to 1 divided by the same number raised to the positive power. Okay, so an example here, we could have 3 raised to the negative 2 is equal to 1 over 3 to the second power, or 1 over 9. And in terms of the variables, x to the negative n is equal to 1 over x to the n power, for x cannot be a 0. Right? Remember that 0 raised to the n power is 0. So if we have 1 over 0, so then this is undefined. Right? Okay, and so then that also will answer your reflection question number 1. Why does there need to be an exception for the second rule in the case that for x is equal to 0? Right? So for a negative exponent using x is 0, would put a 0 in the denominator, and division by 0 is not defined. Okay, so let's go through some example. Right? So if we were to have 5 to the 0 power, then the answer would be just 1. Or if we have, let's say, 5 to the negative 2, then it's a negative, then we will write this as 1 over 5 to the second power. So the 2 become a positive in the denominator, and so this will be 1 over 25. Okay, so let's continue on. So here, saying that a radical expression is an expression that contains a radical symbol. Right? So for an n root, a is called the index. My mistake, n is called the index and a is called the radicand. N must be an integer greater than 1, and a can be any real number where when n is odd, must be a non-negative when n is even. Right? So when n is 2, the radicand is a square root, and the index 2 is also not known. Okay, so then what is saying that if you have a n root of a, right? So we say that if n is an odd number, then a could be any number. Right? But then if n is an even number, a must be a positive number. Okay? Right? And then say that you can write a radical expression as the power. So here is an example. So we have 2 to the third power raised to the second power can be written as 2 to the power of 3 times 2, or 2 to the 6th power. Right? And now for the radical, remember that there's a 2 here that we don't write. So then this can be written as an exponent. So this is a to the power of 1/2. So if we were to give you the square root of 5, then this can be written as 5 to the power of 1/2. Okay, and then or for any index, right? So then we have this. So then for the n root of a can be written as a to the power of 1 over n. So let's try this example. So we have 64 to the power of 1/3. Right? So 64 to the power of 1/3. Okay, so this can be written as 2 in 2 different ways. So then this will become the cube root of 64. Right? But 64 is the same as 4 to the third power. So the cube root and the third power, they cancel out, so your answer is 4. Or we can solve this in this form. Right? So then we say 64 to the power 1/3. Well, 64 is 4 to the third power. and raised to the 1/3. So this becomes 4, 3 times 1/3. So this reduced to 1. So 4 to the 1 power. So the answer is 4. Okay, so let's try example 2. Or example B. So we have 81 to 1 over 4 plus 9 to the 1/2. Right, so this is the 4 root of 81 plus the square root 9. But 81 is same as 3 to the 4 power, and 9 is 3 squared. So the 4 root and the 4 they cancel out, the square root and the 2 they cancel out, so we have 3 plus 3 give us 6. Or we can do using exponent. Right? So let's do this. So we have 84 to the 1/4 plus 9 to the 1/2. So say 84 is 3 to the 4 power raised to the 1/4 plus 9 is 3 squared raised to the 1/2. So this is 3, 4 times 1/4 plus 3, 2 times 1/2. So this reduced to 1. So we have 3 plus 3, the answer is 6. Okay, so can every guy try these two out? Right, so you can solve it using the square root or using the exponent. Right, so let's try number 4. Okay, alright. Right. Okay, so this is the answer from our book. Right, so let's continue with our notes. Okay, so now we have our rational exponent. Right, so given that for any integer n greater than 1, the n root of b can be written as b to the power 1 over n. You can use the power of a power property to define b over n for any integers. Okay, so we went through this already, right? Okay, so let's go through some examples. Okay, so for example A, we have 27 raised to the power of 2 over 3. Okay, so then your textbook show you how to solve it using the square root. So I'm going to show you how to solve it using the exponent. Right? So then 27 is written as 3 to the 3rd power, and it's raised to 2 over 3. So then this is 3 to the power 3 times 2 over 3, so the 3 they cancel out. So this gives us 3 to the 2nd power, so the answer is 9. Right, so for B we have 5 to the power of 3 over 2. So to the right of it, your textbook show you how to solve it using the using the radical. Right, so I'm going to show you how to solve this. Okay, now what I want you to do is that I prefer that you change the 25 into 5 to the 2nd power, right? So this gives us 5 to the 2nd power raised to the 3 over 2, so the 2 they cancel out. So this gives us 5 to the 3rd power, so then it would be 125. Okay. Right, so let's try some of these. Okay. Okay, so check your answer for number 5 through 8. Okay, so here are some more example. Right, so the first one is done for you, so work on number 2, 3, and 4. Right, so this can be written as 4 10 to the power 4 over 2, so this reduced to 10 to the second power, so they give us 100. Now for number 4 is a bit tricky, so we can write 32 is the same as 2 to the 5th power. So the 5th power and the index 5, they cancel out, so the answer will be just 2. Right, so for number 5, 6, 7, 8, they say that rewrite each expression using the fractional exponents. Okay, so if we want it, you got to write it as a fractional exponent, so do not solve for it. Okay, remember that your index will always be your denominator. Okay, but then 64 can be reduced, right? So 64 is the same as 4 to the 3rd power times 5 over 6. So 3 and 6 can be reduced, so your answer for number 7 would be 4 and 5 over 2. And this will be just 10 to the 1/2. Okay, and so here are some more example. Right, so remember that we can solve this two ways. You can either use the radical or use the exponent. Right, so I'm going to show you two ways to solve this. So this 16 is the same as 2 to the 2nd power times 1 over 4. So this can be reduced, would be 2 to the 1/2 or square root of 2. Right, or you can use your radical. So this is the 4th root of 16, but 16 is 4 squared. Right? Oops, I think I did the top part wrong. Let me fix it. So this is 4. So 2 over 4 would be 4 to the 1/2. So reduce to 2. Let me fix my error. Okay, so this is 4 to the 2nd power raised to the 1/4. So then they cancel, the 2 and the 4 cancel out, so this gives us 4 to the 1/2, so it's the same as 2. And for 27, so this is the cube root of 27, but 27 is 3 to the 3rd power, so that cancels, so your answer will be just 3. So that's cancel out, so it would be 4 to the 3rd power, so your answer would be 64. Okay, so please check your answers. Okay, so can we get try now number 5 and 6 on your own, and then I'll give you the answer in a minute. Okay, so for number 5, you can use the radical to solve your work, or you can use the exponent, right? So then change 32 to 2 to the 5th power and 3 over 5, so that cancels out. So 2 to the 3rd power will give us 8. Okay, so let's try number 6. Okay, so then for number 6, this is one way to solve it using the radical. So I'm going to show you how to use the exponent. So that they cancel out. So we have four to the, oops, my mistake. Let me change those 4 into a 2. So that's cancelled. So 2 to the 5th power minus 2 to the 3rd. So then this gives us 32 minus 8. So the answer is 24. Okay, so let's elaborate for number 7. Okay, why can you evaluate an odd root for any radicand, but not even root? But even root require non-negative radicand. So here it's saying that, for example, if we can have the cube root of -8, right? So this is the cube root, the same as -2 to the 3rd power, so reduced to -2. Then if we have an even number, so for example the square root of a -4, then there we would have this, this will be a non-real solution, right? or undefined. Okay, so that's the end of our notes for module 3.1.